Hey Celia, this is Mr. B. So rate, time, and distance. Wanted to give you a little bit of a boost. There's Lily and Jordy hanging out, having fun. This is when she was like a year old. But anyways, on to the problems. Okay, so I completely agree with you that this stuff is confusing. It's all of what's in the details. So first thing I noticed is that when they're talking about time, they're not talking about like the time of day. They're talking about like an hour or minutes or something like that. So let me show you what I mean by that. So for the first one, so when it says at noon, that's for like later. That's for like when you're done solving the problems. First, you got to set up your equation. So the first one is, it says the private plane left Austin for Los Angeles, and it's 2,100 kilometers away. So it's flying at 500 kilometers per hour. So there, where the kilometers per hour is your rate. So I'm going to do 500 for my rate. And then for the jet says that it's going at 700 kilometers per hour. Now we get to time. So time is like, as I was saying before, like in specific units. It says 1 hour later the jet left Los Angeles. So the time would just be like a variable. So I'm just going to call it T. T for time. You could do X for time. It doesn't matter. Now for the jet, and this is a little bit confusing, but it makes sense, is that since it says 1 hour later, it'd be T and then minus an hour. And then all we have to do here is if I take the rate times the time, I get 500 T. And then the jet is 700 times T minus 1. So I have these two right here. Now the question is, what the heck do I do with them? So the question asks itself, or asks you, at what time do they pass each other? All right? So what time do they pass each other is what we're looking for. And that's where this 2,100 kilometers away comes from. So to set up my equation, I'd have to do the plane, which is 500 T, and then I would do plus 700 T, parentheses, T minus 1, and that's going to equal the 2,100 kilometers. Okay, and then by solving for the time, we can then plug it back in to find out, sorry, I got to erase this. By solving for this variable right here, time, we can then plug it in and see what time do they pass each other. So if I solve this right away, it'll be 500 T plus 700 T minus 700 is equal to 2,100. And then from there, I combine like terms and I get 1,200 T minus 700 equals 2,100. And I'm solving for T here, so I got to add 700 to each side. So I get 1,200 is equal to, it's 1,200 T is equal to 2,800 kilometers, or just 2,800. From there, I get a ratio. Because if you divide this, you're going to get a decimal, and that's going to give you like 2.3 hours, and you're going to be a little bit off. So what you got to do is you're going to divide by 1,200, but keep this as a ratio. So I'm going to move this over. If I have T is equal to 2,800 over 1,200, I can then reduce that. So then T is going to equal, the biggest number that I can think of that can go into both is 100. So that'd be 28 over 12. I can still reduce that. The biggest number that's going to go into both of these would then be, let's see here, not 7, so 2. So that would be 14 over 6. So there's even a bigger number that can go into that. So that'd be 7 over 3. So then from there, let me make sure I got that right. Yeah, so there'll be 7 over 3. So if you were to do it and make that and divide that, that'd be 2.3 hours. But the question is, at what time did they pass each other? So I would probably not do the 2.3 hours. I would leave it at 7/3. And I'm going to take 7/3 and 7/3. Let me get my calculator out here. So 7/3, or even 7 divided by 3 is 2.3 repeating. And then I'm going to multiply that by 60 minutes. So that's a total of, So that's going to be a total of 140 minutes. Now we can convert that into time. So how much time is that? Well, 140 minutes, and then you divide it by, there's 60 minutes and 1 hour. So that gives you 2 hours and 20 minutes. So the difference in time is 2 hours and 20 minutes. Then we go back to at what time did they pass each other. So what I'm going to do is add whatever I get in time-wise to at noon. And it should be noon plus 2 hours and 20 minutes. So that'd be 2:20 p.m. And that should be your final answer. All right, so for this next one here, erase so I can see what I'm doing here. So at 8 a.m., that'll be for later. We're not worried about that right now. The Smiths left a campground. They're driving at 48 miles an hour. So there's your rate right there. So the Smiths are going 48 miles an hour. Let's look for what the Garcias, what their rate is. So the Garcias left the same campground and followed the same route, driving 60 miles an hour. Okay? At what time did they overtake the Smiths? So the other piece of information is that we don't know how long it's taking them, right? We all only know is that they left 20 minutes later. So the time would just be for the Smiths, since they left first, it'd be X or T, whatever variable you want to use. I'm going to use X, and then since this is 8:20, this is 1/3 of an hour later, right? So 20 minutes is 1/3 of an hour. So it would be X minus 1/3. So then if we do that and we just multiply across, I get 48X. And then I also get 60 multiplying, parentheses, X minus 1/3. So what is the question ask? At what time did they overtake the Smiths? Meaning, so the Smiths leave first, and then after 20 minutes, the Garcias. So at what point do the Garcias pass the Smiths on the highway? So what I would need to do is find my other piece of information, and I would have, so at what point, I would just set these equal to each other. So 48X is going to be equal to 60X minus 1/3. Because they're going to be equal. Eventually, they're going to be equal to one another, and then the Garcias, since they're going faster, they're going to overtake them. So I would just do 60X, and then 60 times 1/3, like we said before, is 20. Forgot the X there, and this is an X here, and then I would have I'd minus the 60X on each side. And I would get negative 12 is equal to X is equal to negative 20. And then from there, I would divide each side by negative 20. And I would get x is going to be equal to, since it's divided by a negative divided by negative is going to be 20 over 12. So we want to know how many minutes that is. So what I'm going to do is I'm going to do 20 over 12, or 20 divided by 12, and then multiply that by 60 minutes in an hour. So 20 divided by 12 is 1.6 repeating, times 60 minutes. So that's going to be 100 minutes. So x, our time, is going to be equal to 100 minutes. How many minutes is that? Or I'm sorry, how many hours is that? We know that there's 60 minutes in an hour. And so that's going to be 1 hour and then 20 minutes. No, sorry, not 1 hour. Yeah, 1 hour, 40 minutes. So then I go back to, they left at 8 a.m., right? So then I'm going to add an hour and 40 minutes to 8 a.m., and that's going to give you 9:40 a.m. All right. So for this one, Quan hiked up a hill. Zoom in a little bit here. Quan hiked up a hill at 4 kilometers per hour, so that's Quan's rate going up. So that's 4 kilometers per hour. In fact, you don't even need to put the kilometers per hour, so his is 4. And then going down is 6 kilometers an hour. His total hiking, so that's going to be this whole thing, is going to be 3 hours. So how long is it going to take? How long is it going to take Quan to get up? How long did the trip up take him? So this one's a little bit confusing. It took me a while to figure it out, but I know that going up, it says it's just going to be a certain amount of time. So T for time. And then going down is going to be, since it was a total of 3 hours, 3 minus T. So then when I multiply this, I get 4T, and that's going to be set equal to 6 and then times the 3 minus T. So essentially what it's saying is it's going to be 6 minus the 3 hours, or 6 times the original amount of time minus the time it took to get up the hill. A little confusing, I know. I hope you're staying with me. So I'm going to set this equal to this right here. So 4T, so the time going up is going to be equal to 6 and then 3 minus T. So then 4T is going to be equal to 18 minus 6T. I'm going to add 6T to both sides. So 10T is going to be equal to 18. Then I'm going to divide, and I'm going to get T is equal to 18 over 10. And I'm keeping that in a fraction because, again, what I'm going to do is see how many actual minutes that is. So I can actually reduce that. I know that 2 goes into both of these, so that's going to be 9 over 5. So then from there, I do 9 divided by 5, and then times 60. So 9 divided by 5 is 1.8, and then times 60, that's going to be 108. So we have so our T is equal to 108 minutes. And then the question is asking, how long did the trip up the hill take? So what I need to do is just go to whatever equation I have for up, and I can see that it's 4 times T. So 4 times 108. Or actually what you can do, I forgot to do this, sorry. It's 108 minutes, so to put this into like hours and such, you could do that right away, but it's easier if you just do the 108. So 4 times 108 is going to be 432 minutes. So then 432 minutes divided by 60 is going to be, so hold on a second here, I might have something wrong. I'm confusing myself. Okay, I immediately find out what I did wrong. I don't have to do 4 times t. So the time right here is just 108 minutes. And it's asking, let me erase this. And it's just asking, if you're going up, how long is the time going to take you? And this is just a t. And we know that t is equal to 108 minutes. So going up would be 108 minutes. Now, if I needed to do, say, 3 minus t, or I'm sorry, if I needed to see what it would be to go down, I would do 3 minus t. So what you can do is, like, you would just do 100, see how many minutes that is. So that'd be like 108 minutes divided by 60 to put it in hours, so it'll be 1.8. And you don't have to do this. I'm just letting you know, this is just a for frame of reference. So 3 minus 1.8 would be 1.2. So if you wanted to go down, it'd be 1.2 or 1.2 hours. So it would be 108 minutes, or in other words, that would be 1 hour and then 48 minutes. All right, so the last one here. Johnny had driven for 2 hours at a constant speed when road repairs. Jenny actually had forced her to reduce her speed by 10 miles an hour for the remaining 1 hour of her 152-mile trip. Find her original speed. So let's just put in what we know. So the time, we know this one, the time is 2 hours, right? And then we know for at a slower speed, she had to go for 1 hour at a slower speed. Then we don't know what the rate is, but we do know that she has to reduce her speed for 1 hour. So we'd have to put x minus 10, meaning x minus 10 miles an hour. So then if I just multiply this across, I get the distance for the original speed is 2x. And at a slower speed, it would be 1 times x minus 10. Now we need to find what x is. So I'm going to add these together and set them equal to the 152-mile trip. So I'll have 2x plus, and that'll just be x minus 10, because it's multiplied by 1. I'm going to set that equal to 152. So that'd be 3x minus 10 equals 152. Then from there, I'll add 10 to each side. So 3x is equal to 162. And then I'm going to divide. So if I do 162 divided by 3, that'd be 54. So x is going to be 54. So we need to find her original speed. And her original speed, the rate, is just x. So it would be 54 miles per hour. Again, if it said what was her speed for an hour at a slower speed, you would just plug this x in for this equation. So it'd be 44 miles per hour at a slower speed. I hope this was helpful. If you do have any other questions, feel free to send me back an email. I'm out tomorrow. But yeah, just send me an email or ask Mr. Klaus, because he's smarter than I am. All right, hope you have a good one. Hope this helps. Thanks.